We saw in the last video that soil is made up of a number of individual particles. Many soils are formed when soil particles suspended in water are deposited in rivers and lakes. The first thing I want to explore is how this deposition under gravity affects how soils behave. I have developed this piece of apparatus that simulates the effects of gravity. The particles here are circular discs of different diameters, and they are resting on a plastic sheet which is drawn across the bottom here by means of this roller. When I turn on the machine, the plastic sheet drags the particles to the bottom in the same way that gravity drags soil particles to the bottom of a river or a lake. In real life, gravity gives the soil particles weight, pulling them downwards. In this model, weight is simulated by the friction between the soil particles and the moving plastic sheet. And you can see that they're settling on the bottom and they're now shuffling around and forming themselves into an arrangement of particles. You can see these near vertical columns, and they're very important because it means the soil is stronger in the vertical direction than the horizontal direction, and that's because this has been deposited under gravity. Gravity acts vertically. A soil deposited, laid down under gravity, is stronger vertically than it is horizontally. Now we're going to look at another very important effect of gravity. We're going to see how it affects the strength of the soil at different depths. So we'll do an experiment with a footing. Here it goes. You can see it penetrating in, and it's reached this depth here. So the weight of the footing is being carried by the strength of the soil at this depth. Now we're going to increase the weight of the footing and see what happens to the penetration. And we see the footing now penetrating further into the ground. Let's see how far it goes into the ground with 4 batteries acting on it. There it is, it's come to equilibrium, actually at a greater depth than the lightly loaded footing. So why is this? Why is the strength of the soil greater with depth? You'll know from your mechanics classes that the shearing forces or frictional resistance between two surfaces depends on the magnitude of the contact forces that are pushing the two surfaces together. When the contact forces are small, the shearing forces or frictional resistance is low, and they can slip past each other. When the contact forces increase, the shearing forces or frictional resistance goes up, and it is much harder for the two surfaces to slip past each other. Now, going back to our experiment, gravity acts, the soil has weight. The deeper you go down, the greater the forces between the particles. So the greater the shearing resistance between the particles. And that's the explanation for the strength increasing with depth. So, summing up, we have seen that the soil is stronger vertically than it is horizontally, and we have seen that the strength of the soil increases with depth. Both these very important effects result from the soil being laid down and acted on by gravity.